who is the longest traveler here? 32 kilometers. I know that one. Anyone else? 26. How was the traffic today? Manageable or terrible? Not bad, right? At least yesterday when I was coming back from airport, it was like manageable, and I felt like, okay, it's probably people are getting into more holiday season or holiday mode. Anyways, welcome to JFrog, and my name is Biplab, and I take care of marketing for JFrog, and we are really happy to have you here at this meetup. We really don't want to bore you with JFrog insights and what do we do, but have you done any research like, okay, you are going to JFrog office, what do they do, what kind of work which JFrog is doing in the industry, any idea, any thoughts? Feel free to share. Artifactory storage, binary distribution, okay. Anything else? Have you done any research more than like these names, Artifactory and all? No, right? No, it's okay. Absolutely fine. Because when it comes to the DevOps world, these names are very common. But when it comes to implementation of those, then you will actually be using those or leveraging some of those concepts. Otherwise, yeah, as long as you know the Artifactory or maybe the binary management and those kind of concepts, it's okay. It's more than enough to be part of JFrog and be our guest. So thank you for coming here. Just to give you a little context that what do we do? So when it comes to the DevOps loop, I'm sure you would know that Devops Loop, right? So that's pretty much your development lifecycle. So when it comes to the entire development lifecycle, we manage your binaries. The moment you finish your codes and you compile your code, it gives you a binary, right? So the binary could be in any format. So if it is a Windows, then you get something like a DLL or EXEs, etc. If it is Android or Mac or something, then you get some other binaries. The moment you have the binaries, we help you manage it. We help you store it. We help you, do all sort of a compliance and security verifications, etc. So that's what we do. So we pretty much take care of end-to-end binary journey. And we help you manage the entire life cycle of your, the development process. So that's what we do. We have a pretty decent set of, office here. So as of now, we host somewhere close to 150 plus employees, and we take care of support, R&D, and then sales and marketing folks are here, and then operations. So that's what we are in JFrog India. We are available in multiple countries. So I think it's around, 20, how many countries? Yeah, so 24 odd countries where we exist, and 1,300 plus employees what we have. So that's about JFrog. Any questions before I hand over the mic to my colleague here? No? Good? Alrighty, I won't bore you much. So let me invite Gyana. He is the first speaker today, and he's going to walk you through the, how he is talking about building web apps and what are the journeys behind that. Do leverage this opportunity, ask questions as much as you can, and we'll be happy to take any questions. I know Jayshree is the second speaker here, so yeah, do leverage this opportunity, and hopefully the organizers will also come, and then we can have more interactions, more engagement. Okay? Alrighty. Gyana, over to you. Yep.
Hey guys, can you hear me? Very good evening, everyone. Okay, thanks Biplab for the introduction about JFrog and the journey JFrog had. And we had a journey together, okay, to build the binary systems here at JFrog. So my name is Gyana Ranjan Panigrahi. Okay, I joined JFrog 1.5 years back. Okay, prior to this, I worked for Broadcom around 7.5 years. So I have overall around 10 plus of year of experience into Java, distributed system, big data, as well as, okay, I work for Spark and Scala as well. So today, okay, we're gonna talk about, okay, the how do we build the web application using Spring Web WebFlux. What do you mean? I mean, we generally typically, okay, when we write any program or any of the architecture today in world, okay, we use the MVC pattern. It's a very pretty simple pattern, right? So what do you mean by a MVC pattern? Which is nothing but you have a model, you have a view, and you have a controller, right? So what do you mean by a MVC pattern? So how does it interact? Okay, how does it interact? What are the type of mechanism that it has? And how does it different from Spring WebFlux? So basically, okay, I'll talk about before starting this. I don't know. I'm not able to. One sec. Okay, cool. Okay. So before we jump into reactive programming directly, okay, let's talk about what do you mean by a blocking and non-blocking call. That's very important when you talk about reactive programming. So when you talk about MVC, it's all about, okay, whenever you have a request, okay, the servlet is going to create a thread for you. Okay, it will process that thread, write the data back to the DB, get the response back, and send the response back to the requester, right? That's how a typically MVC pattern works, right? Now, how do we differentiate between a blocking and non-blocking call? Blocking means, okay, whenever a request comes, thread will be created, it will send the data to the DB, okay, then get the response back and send the response back to the requester. This how, so till that time, okay, the request, okay, is being not processed, okay, the thread is going to be blocked, isn't it, right? So non-blocking means, okay, so you have a set of thread pools, okay, so whenever a request comes or you have multiple threads, let us assume that you have 5 threads, okay, which is requesting for a data to be get from some of the data, okay, maybe from the DB or maybe from somewhere else where you wanted to retrieve it, okay. So what happens in that case is that, okay, you have a set of thread pools and you have a event data, okay, so the event loop will be processed. So whenever you send the data along with the event loop, okay, so that's it. Whosoever is the thread which is available, okay, into the thread pool, okay, that is getting assigned to the requester, okay, and it keeps on doing the data. It doesn't block you. Suppose you are reading the data from the DB and you have a one thread which is reading the data, and next set of thread you are writing the data, it doesn't get blocked, right? So these are basically the concept of blocking and non-blocking, and how does reactive programming help you, okay, to have your non-blocking concept, right? So basically the stack, reactive stack, okay, got introduced in Java 8 onwards, okay, and which has Java 8 onwards, and it got introduced in WebFlux in Spring 5.0 version onwards, okay. Now when does it started? How does this Spring WebFlux journey started? Prior to this, okay, the engineer from Netflix, okay, he has started writing a projector Reactor. He has given a task, okay, to just write a subscription and publisher based model. He has analyzed it, okay, he found that, okay, this publisher and subscriber based model is going to be work for a larger audience. So he has open sourced it. So next journey it started is that they have they have combined with the Java developer from Oracle, okay, and they have started introduce the same concept in JVM in Java 8 onwards, okay. Now, okay, when Spring comes into picture, so you have a Spring, right? Okay, so when the Spring WebFlux comes into picture, so I'll talk about that. How does Spring WebFlux helps you to write a reactive program? Basically, you can still write a reactive program without WebFlux as well, okay. But I'll just talk about how does or what are the out-of-box solution that Spring provides, okay, so that you can easily write your Spring WebFlux program. So basically, okay, these are just the theory. I'll go at the end of the slides, I'll go through a demo, okay, basically how a publisher, how does a subscriber, how do you send the data, and where this subscriber comes into picture, and how does okay, it basically process the data and send the response back to the user. So basically, okay, this reactive concept started from observer pattern. You might be knowing some of the design patterns of the Java, right? It started from observer pattern. Basically, you have an observer, okay, so it basically observes to any event that occurs, okay. So whenever there is an event occurs, okay, it will send the sub or the consumer saying that, hey, I have an event, whosoever is the consumer, please consume that event, right? That's a very your observer pattern. So basically the concept started from there, okay. So that's where it is. Reactive programming, being modeling of data and events as a observable data stream. Now the thing is that, okay, now let us start about, okay, how do we write a reactive program? Now you have a, don't start from WebFlux, okay. So you have basically typically your MVC application, right? You have a container, servlet container, right? Okay, so whenever a requester comes, okay, it will create a thread for you, right? Till that time it does its operation, the thread gets blocked. Now let us think about how does I write a reactive program wherever my thread doesn't get blocked. What do you need? That you just need a thread pool, right? Okay, you need a thread pool, okay, which will basically request, the thread will be assigned to that particular requester, and the remaining request, okay, you can still assign wherever the thread pool available is. That's where the programming starts, right? Okay, next. Okay, basically this is basically which I talked about, okay, which is a blocking request. Now if you see here, the request which is basically coming into a presentation layer, there is a thread getting created, right, which is getting blocked here. Till that time the worker thread processes, send the response back. Okay, this is where the async programming starts, which is basically your Spring reactive or the reactive programming starts. So see here, okay, whenever there is a request comes here, what does happen in the event loop? So event will be occurred, okay, with its callback. Okay, so this has a fixed set number of thread pools which is being available. Okay, the handler, event handler, which is nothing but is a subscriber, right? Okay, you just emitted a request. Okay, there should be a some subscriber who has to be, what do you call, the handler, basically, right? So once the operation has been done, okay, it will, so basically a thread will be assigned from that thread pools. Okay, then the event, okay, it will send the response back along with this event loop for the callback which is being requested. Basically the callback will have all of your information whatever you have been requested. Now why do we need, okay, reactive programming? Now let us assume that, okay, you have a producer and you have a consumer, right? Producer produce the data continuously, and consumer doesn't even, I mean, suppose let's say you have emitting a data for a second, around 1 lakh of data you are emitting it, but there is a request, or the consumer, okay, doesn't even know, okay, I mean, he is not able to receive the data. So what will happen in that case? Okay, basically your system will fail, right? Okay, that is the concept of back pressure comes into picture whenever you have a reactive. So you need to, I'll show you actually how back pressure works in reactive programming. So basically, okay, so this is very important, back pressure. It has, so this has been introduced, okay, in Spring. So there is a concept called Project Reactor, which is a library which is available in Spring. Okay, that is underlying on as part of your Spring WebFlux. Okay, now I have already talked about this, so let's talk about what do you mean by back pressure. You got it right. So let's say I'm emitting 10,000 of records in a second, but my consumer is not able to handle this. What will happen? The producer is keep on producing the data, but wherever there is no consumption is happening, right? Now let's talk about Kafka a little bit later, okay? Because Kafka, has provided an API where Spring WebFlux also supports those. WebFlux still can consume the APIs from the Kafka. I'll talk about that, okay? No, that is, sorry, come again. So that's somewhere around messaging system that you are talking about, right? So we don't have messaging concept right now. I haven't talked about that. I'll talk about that as well, messaging system. I'm just talking about here how Spring provides a producer and consumer application without your messaging system. Exactly. No. Exactly. Yes. No. It's just yeah. There is no under. Exactly. Correct. There is no possibility of messaging system because always talks about your client and server communication, right? Okay. So let's say, okay, so how do you control this? Okay, how do you control your breakfast? So there are three ways, okay, which we can do it. Either, okay, the publisher has to know how many data that consumer can consume, which is very, not an ideal case, right? I don't know actually how much your subscriber is, how many are the subscriber, or how many data they are going to be consumed. The second case is that you have to limit your number of data that you are producing to a subscriber or the consumer, right? The third case is, okay, you just cancel those many data where, okay, how many subscriber can consume and the remaining data cancel. This is what, suppose you are publishing 10K events per second, okay, and consumer can only consume 7.5K per second. What will happen? The 2,500 of data, we're going to lose that, right? Either we are going to lose that data or we are going to cancel it, or your system is going to fail, right? Okay, if you keep producing 10,000 of data of every second, right? So how basically this is where your WebFlux comes into picture. So it provides many capability, okay, to handle it. Okay, I'll show you a demo, typical demo actually how WebFlux helps you out, okay, basically in this scenario particularly. Okay, now, so this is basically, okay, WebFlux basically has two publishers. One is your mono, second one is your flux. Mono is used whenever you have only single set of consumer that either it is a 0 or a 1, basically only one item that you wanted to redeem, which is not typically case in the case of a huge large data system, right? Okay, we basically talk about larger data system, then flux comes into picture, which can produce 0 to n number of record, and the consumer can consume those records, right? So flux is basically your returns your 0 to n elements of data. So let's talk about a demo, okay, and I'll just, I have an application, I'll share this with GitHub. So before we'll start, okay, I'll just explain you, okay, how does where exactly. So in your MVC application, you need a controller, right? So here in this case also, suppose you are requesting an API or an endpoint, okay, where, okay, the consumer or the client can consume it. What do you need? That you need to expose that, right? How do you expose it in Spring generally? Okay, how do you expose it? You need a request handler, right? Or you need a controller basically. So we'll not use the typical Spring MVC controller. We will use your Spring WebFlux controller, which is nothing but is your router, which is called as your router. So basically, okay, this is where, okay, you see about request router. Now when you declare a so if I go about request router, so this is your first class. See, there is no, I mean, nobody is using it. Basically, this is your starting point of your flux, correct? So now what will happen? So I have a stream of weather events. So what I need to do in this application is that for every seconds, okay, I need to consume, okay, what is the temperature, what is the humidity for a particular time frame, okay. So every seconds I need to consume that. So there are a publisher which is publishing the data, and there is a consumer who are going to consume it. How for that particular second, what is your basically humidity, temperature, and the other set of data. Okay, so basically you have a weather streams here. Okay, now see, this explanation I have written to help you guys. Whenever I expose this into the GitHub, you can read it so that it will be easy for help you. It will be easy. So I have a get application, I mean get API, which is basically a weather stream API, okay, which accept a request handler. Now, okay, you have a router. Now you're gonna hit that API. Who is going to accept that? You need a handler, right? Okay, so basically you need a handler who is going to hold that API and process for you. So that is nothing but, okay, here if I request handler, okay, and this is your handler. So this is the typical Spring concept of dependency injection. So in request handler, I need a weather service. Okay, that weather service, which is nothing but is your model, which which holds all of your modeling of data, like your whatever it is. Let's say, so in this case, okay, you have these many data. So I have basically created three functions. One is the service class basically, okay, which holds your speed, humidity, and the temperature. I have hard-coded this data. So this is basically an array of what you call speeds, and humidity is your array of humidity and the temperature. Now what I am going to do is that every seconds I'm going to produce this. Every seconds I'm going to produce it. So there should be a consumer basically who is supposed to listen this, right? So how is gonna do it? So I told you, right? Okay, so So if you are producing n set of data, you need a flux, right? If you are producing only one element, you need a mono, either 0 or 1. So if you are producing a mono, you need a mono response. And if you are producing a flux, which is basically a 0 to n number of data, you need a flux response. As simple as that. Now, so there are three things here, right? Wind speed, humidity, and temperature. I need to combine it so that in a second I need three set of information. For every second, I need wind speed, temperature, as well as your humidity. So how would I combine this now? That comes into picture, right? You cannot call all the method. You cannot keep on calling all this method to get it, right? So WebFlux comes into picture here. It provides a concept called zip. Okay. So if you look up, so this is basically from okay, before that, okay, I need to generate it, right? Okay, you need, so this is basically your service. This is your data stream. Consider this is a data stream which contains your wind speed, humidity, and temperature. Okay, now this stream of data I need to generate it. So how do you generate it? Flux dot from stream, which is basically a producer. This acts as a producer. Basically I need to generate it. How are I going to generate it? Flux dot, okay, from stream. Okay, there is a method called in stream called a generate, which will basically generate this set of records. Okay, so this is basically a weather event which I talked about, which is a model. Model stores your weather, okay, which has temperature, humidity, and this is normal POJO classes. Now you got wind speed, you got humidity, you got temperature. Now you need to combine it, right? You need to, every second you need to produce these three set of data, right? Okay, how are you going to zip it? So you basically need to combine both, right? So Flux provides, okay, lot many APIs. Okay, out of this there is an API called zip. So what does it do is that it will get the humidity. It will get, so it will wait for, so first you are getting the temperature. So it will wait for the result to be produced. It will wait for the humidity result to be produced. It will wait for the wind speed to be produced, and its local time it will capture, and it will combine all of this, and it will return it. Basically, this zip method, which is nothing but an event. So I'm going to produce an event with all this set of data. Okay, so that is basically your producer. Now when I run this application, so if I run this, generally I should be able to produce it, right? Okay, now, okay, sorry, I have started the client application. Let me start this application. Okay, now it is being started. You can't see it, the producer is producing it, keep on producing. There is no client right now who is going to consume it. I started keep on producing the data. So there are two ways to do it. Okay, there is no client now, right? Server keeps on started producing. Now how do you basically your consume it? So you just need to, so I have run, so before that I just talked about, so this WebFlux runs on a native server. Okay, it is an inbuilt native server, which is a non-blocking one. Okay, like normal user Jetty is your blocking server, but it uses your native, which is a non-blocking web server, which is embedded with Spring WebFlux. Okay, now when I start it, so it started consuming the data. If you can see, so what are the data? Server producing. So every second, okay, it is producing your temperature, humidity, and wind speed. Now you have a subscriber, okay, who is basically listening. So I didn't write anything. It's just a call command. Okay, it just you just exposed me this API called weather stream. Okay, which is basically producing this, and this guy is consuming it. This is basically my client. Now I'm gonna write a client program, right? Okay, you cannot simply run this what you call command to consume this data, right? So I'm gonna write a, so Spring provides another client which is called web client. Okay, we need to use your web client to consume this set of results. Instead of curl, okay, we will be writing our own client program which will basically consume it. So what do you need there? So the producer is producing, so you need a consumer which will basically consume the data, right? So how do you consume it? Basically, okay, there is a subscriber basically who is going to subscribe it. Okay, so I'll just show you here. So this is again a microservices. So basically, okay, I will just, so now, okay, I'll stop this client. Okay, you still are producing it. I'm just stopping the client. Now when I run my program, client program, ideally the client should be able to subscribe those data, right? So how do we do that? So basically you Spring WebFlux provide web client. Okay. Earlier it was REST web client, okay, which has been changed with later version of Spring, which is providing a web client, which is especially for your WebFlux. Okay. So how web client dot create. So basically, okay, this is going to listen to, so if you look at the about the my application which started on 8080 port on localhost. So you have to know it, right? Okay, which are the ports that your server is gonna start at, right? Okay, you can maybe you can expose this in a property file and you can read it. For now I have hard coded it. So whenever this application comes, okay, this client application which is listening to this localhost server. So here the URI, okay, what is the URI? So in the curl URI, okay, if you talk about it, this is basically my URI, right? So you are going to hit those URI to get the data, right? So this is dot URI. Now you need to retrieve those data, right? The method called retrieve, okay, where okay you can retrieve the data. Now body to the flux, okay. Now so your subscriber, sorry, your publisher is writing this set of data, right? So you need a subscriber which can listen to. So you need a model again in the client, okay, which basically can listen this. That's where, okay, in my client application, I have created this model here, okay, which is nothing but same model. Whatever the data that you are producing it, you need to listen for this. That's where I have created a client. So you just need to subscribe. There's a method in client called subscribe, which basically subscribe the data which is getting produced. Now, when I run this program, when I run this client, ideally the producer, whatever the data is being produced, should be subscribed here from the client. Let's run this and see it whether we are able to subscribe it or not. So every second, okay, we are producing this result. Now, when I run this, cool. Now, if you see it, okay, it is started subscribing the data every second. Whatever the producer is producing it, it started consuming the data. So this is basically a typical what you call reactive programming, where your producer is producing, okay, and the consumer is basically listening. Now there is no concept of back pressure here. Okay, nothing has been applied here. It's just a simple producer consumer problem. Okay, that is using your Spring WebFlux. Now when is your suppose let's say okay, I just wanted okay 2 information only every second. I just wanted to produce two emitter. I mean, the producer, I want my subscriber, okay, to produce only 2 set of information instead of every second it is writing. How do I do that? That's where the concept called, because I want to control how much of data that a producer wants to produce it. The subscriber wants to control it. So there is a concept called, okay, subscribe has basically 4 methods. Okay, so that is one is your on next. Okay, another is your on subscribe. This is your in case of error, in case of complete. Okay, so I want my subscriber to emit only 2 set of information. I mean every second I want only 2 event has to be produced. How do I do that basically? So you just need, okay, so let me, so this is gone right now, right? Okay, this is so this subscribe, I'm just commenting it, and now sorry. So here what I did, okay, on subscribe, I have a request only for the producer to request only 2 set of data. So you just mention subscription dot request 2. That means a producer for every second, okay, it is going to produce only 2 set of information, right? Okay, so this is where, okay, this is where you can control it, right? You don't want your system to be overwhelmed by the producer which is producing the data. You can control, right? Okay, how many data I want. So as per the request, I mean, as per subscription wants, okay, he can request the producer, okay, to produce the data. So this is where, okay, in the client, okay, you just need to subscribe those requests. Okay, so when I run this, ideally, what will happen? Okay, let me stop this first. Let me stop the client application. Okay, let me restart it again. Yeah. Yes. Yes, because it works on a HTTP TCP mechanism. There is a new event, it will automatically send. You don't need to control it basically. In the subscription, whenever there is a new event, it based upon TCP, and when there will be an event will be created on the publisher side, and the subscriber has to listen it. That's it. Yeah, you can do that. We have, in the subscriber we have a method basically. Whenever there is a change in the event, or there is a new event occurs, you can listen it as well. Instead of controlling how many requests that you want. Right, so even you can check the number of size of the records that you want. Okay, whenever a publisher publishes it, you can still control from the subscriber. I want for a second only 10,000 records to be available, not more than that. Okay, because you don't need that, right? I am the consumer, I am going to consume it, and I want my operation to do on that 10,000 records. Okay, so I can do that as well. Okay, so basically if you look at this, okay, so on subscribe, I am requesting two emissions for every seconds, which is on next. Okay, I have consumed my data, and here, so basically every I'm requesting 2 emissions from the producer. It is producing only 2. Okay. No, not exactly. Okay, you can still embed your Kafka client into this. Okay, it is not just for publisher and subscriber. It is basically a asynchronous programming, right? It's a concurrent model, right? Okay, your requester doesn't have to wait. Okay, for the request. I mean, for the what do you call the container? Okay, which is basically your reactor here. Okay, the project reactor, which is basically a library. It provides a library. It has set of threads. Okay, the thread pools which have been implemented inside the project reactor, right? Okay, so this is not just only for publisher subscriber. I have just taken an example to make you clear. Okay, but you can still use Spring WebFlux for other set of operations, like okay, you want suppose 100 threads, okay, to be created, okay, and you need some operation from the from the response, whosoever you want. Typically, whenever a MBC application doesn't mean that you only use your publisher subscriber. It is just a parallel. It just provides, in the MBC, okay, you have a single thread application, right? Okay, but on top of that, it has a parallel layer that it provides, which is nothing but WebFlux, and underlying it uses project Reactor. Yeah, it's common. It's just an implementation which I did. Okay, it's a common approach. You can still use a messaging system, okay, where a producer can. No, in web also it is supported. Okay, but WebFlux provides a extensive way of using it, because it has its mono, it has its flux. Okay, you don't need to create a thread application. Okay, just producing and resulting. So it has out of the box solution which is being there in WebFlux. Yeah. Sorry. Okay, there are 2 cases here. Okay, so in the Reactor library, okay, there is something called, okay, I have forgotten the name. Okay, it still exposes your all the native language. It doesn't mean that your native, client has to be only in your Java. Okay, you can use it. Just in the whenever suppose you are using a JavaScript, right? Okay, you don't know, right? You have just web client, okay, which is embedded in Spring, right? So you need to write your own client, okay, which is basically listen to this port, right? So you can still write in JavaScript. It doesn't hold you to write your client application only in Java. Now, one more interesting part here is that, okay, it has an what do you call? It still has Kafka provides a lot of APIs. Right? You know about Kafka, right? It is a messaging system. You have a publisher, you have a subscriber, right? Okay, so it has a tight integration. Instead of okay Spring writing into a publisher, okay, and the client listen to it, okay, you can still write your data into a Kafka topic, and this client can still listen it. Okay, there are a lot of APIs available. You can still write only the client program, okay, where you wanted to listen any messaging systems data as well, just like your Kafka. I know about Kafka. I don't know about other set of messaging system whether Spring WebFlux provides or not. Okay, but extensive APIs of Kafka that Spring provides it, where you just need to write your client program, and the producer is your Kafka or some other thing. Okay, for now, okay, as per my knowledge, okay, it has extensive support of your Kafka APIs as well. You are just client, okay, just need to listen the topics. Any other questions? Yeah. I'm not very familiar with JavaScript. I'm not very sure. Okay. I don't know personally. Okay. How? Yeah. I'm not very sure whether JavaScript has these methods. Okay, where you can listen it. Okay. But this is more of an MVC application, right? Okay. It's all of a server model and the view. Okay, which is exactly website. Yeah. Sorry. That is your producer, which is yeah. Different. No, right now it's running on my local. Okay, you can still your client can still, you just need okay to subscribe to this. No, today it's just both are the running on my local host. It's a two different processes running on the same machine. Okay. Block the client or the block the server? Okay. Where do you want to put the sleep? In the client side. So when you put a sleep, okay, it will wait for that moment of time. After that, it will start consuming the data. That means see, okay. So generally, what will happen if I let us assume that okay, I have in here. Okay, now on the next event, okay, I have put 1,000 of milliseconds, or maybe let's put about 10,000. 2 seconds or more than that, maybe 1 minute, right? Yeah. Sorry, come again. If yeah. No, it will be blocked actually. This client will be blocked, okay, for that data to be consumed. So simple. Okay. One minute. Okay, you want me? Okay, let me. Okay, just to be faster too. Okay. It's 20,000. Oh. No, now see. Okay, now see it's got blocked. So it just requested for the 2 emissions, right? Okay. So in the subscribe you just wrote okay 2 emissions. Okay, it came here. So on the next, okay, it just blocked. So it's producer is still producing. If I just run my client here, the outside of it will consume the data because that thread got blocked, but the other thread you can still consume the data. That's the concept basically. This is where you specify, right? Okay, this is where. This is the in the on next method you specify how many requests, or the subscription has all sort of APIs available. Here you are requesting only 2 records. Okay, you can request more number of records or number of sizes or sorry. That yeah, that's the event, right? Okay, event which is being produced by the producer, right? Okay, the consumer has to know how many events it's being produced, right? No, it will stop. It will stop that thread, okay, to produce the data for that particular thread only. But if you start on a single another thread, okay, it will still consume the data whosoever is listening it. Exactly. Okay, it stops producing it. Now if you see it, okay, because if I start my another thread, okay, it will start consuming it, because this is anyway not consuming it, right? Because anyway you are listening to this local, this local host, isn't it? Okay, so you just waited for that 20 seconds. Okay, once it has been finished, a producer, okay, it start consuming the data. That's how it is. So okay. No, yeah. No, this is the generator date, right? Okay, this is not the client side date. So exactly on that particular 1 second of time, but your client is still okay. Yeah, that's how. Correct, right? So basically, okay, if you look, what you are asking about is this one. Yeah, this is. Yeah. Any other question? Yep. Yeah. No, it may not be a sequential information. If in this case here, okay, I've just created a single thread, okay, which is basically producing. There can be n number of threads basically, right? Huh. Yes, you still can use your client, right? Okay, so you can still put a breakpoint on the client method, okay, to see it. Okay, how many number of threads has been executed. So here, if you see, okay, basically whenever you subscribe it, okay, so let's say you have 100 threads, right? Okay, so how many requests? So this is a single threaded application for now, right? You have a multi-threaded application. Okay, so each thread is producing some set of data, but there should be a consumer who is knowing that, okay, this is the data that I need to consume it. All right. Okay, to my knowledge, okay, you still can debug it, okay, using your Spring WebFlux applications only. Exactly. Yeah. Leave it over. No, it is not storing anything. It is just listening. It's a plain. I have just written this line. It's not storing. It's just reading it. It's not. Huh. Sorry, come again. Hmm. Okay. Huh. Yeah, so till the time whatever it is being produced, right? Okay, the consumer will start consuming it. It's not like the data will be lost, right? If see it's as simple as that. This one. So we have waited for 20 seconds, right? So assuming that my client is not being running for that 20 seconds, right? That means producer is producing the result, right? So when you start your client, okay, it start listening to. So the flux. So if you look about it, okay. So in my yeah, it is. So right now, okay, I am storing it here as part of what you call is a normal string array, right? Okay, where I am storing this result. Okay, so now you need to decide, okay, whether you need to talk to some of the DBs, okay, where you can store this data and retrieve it. Yeah, static data, correct. Yeah. Yes. I haven't persisted the data. Okay, actually, right now, okay, if my so yeah, so if I'm stopped consuming, okay, you gonna lost this. Okay, I'm not going to listen it because there is no data is being. Yeah. 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 Today I don't have. I haven't use cases for that as well. I had an use cases. I'll share you that. Okay, where I am storing the data in the Mongo. Okay, Mongo has also extensive support of the reactive library. Okay, I have those. I'll share you that. I have 2 demos basically planned. Okay, so I don't think I am able to do that, but I'll share you those. Okay, where okay I'm persisting the data in the MongoDB. Okay, so I'll share you that as well. Any other question? Time up. This is generally okay in the Twitter or in any of the Facebook application. Okay, it is used today also Facebook uses the Spring reactive application for the notification, mainly for notification, not for everything. Whenever there is an event, okay, you think that okay that events I need to consume it, you can still use it. It all depends actually. Okay, if you this is mainly used for a notification based service actually. So if you don't want your service to be notified whenever there is an event occurs, you can still go for a plain MVC application. And whenever you want your service to be notified whenever there is a change in the event, then you can still use Spring. Okay, thank you guys. Okay, thanks for joining me. Okay, it was nice talking with you guys. Thanks a lot.
3 years actually. So if not JFrog, we should not have started at this point in time actually. We were kind of hesitant. So thanks a lot actually for everybody. And then we have a session from Jayshree on another reactive topic. So anybody has any announcement, they can announce now. We are not going like structured as same as in online. So if anybody has any job requirements or job opening, you can announce now till Jayshree sets up the mission.
Hey, thanks. Hey guys, first of all, okay, quick introduction about myself. I'm Manas. I've been in JFrog for about 15-16 months now, and it's been a great journey, to be very honest. Fun fact, me, Gyana, Biplab, we all 3 joined on the same day. And that's a coincidence, I guess. I lead the talent acquisition for JFrog. Obviously, we're not using this platform for a job hunt. That's not the intention. The intention is to obviously talk about technology and how best we can use it. And thanks, Gyana, for giving an amazing demo and session. I just wanted to highlight the fact that we are definitely hiring and we are up for it. We have many open roles open, and you can go to our career website, look into LinkedIn. We have opportunities for both R&D, non-R&D, tech, non-tech. Not necessarily for you guys, but you have friends, people in your family who are looking out. Do reach out to us, and I'm here post the session as well. We can interact and talk about more. I'll not take more time. I also would like to take this opportunity to thank all of you for taking out time post your office hours. And I know how crazy the Bangalore traffic can get in the evenings. So kudos to you guys. And also it's a different experience for all of us, I'm sure, to see people outside the box. When I say box, the Zoom box, and to realize that we have legs. I'm sure we'll have more meetups coming up in person. We'll get to meet many people in the future. So thanks for coming up, and kudos to all of you to coming in. I'll hand over to her for the next session. And yes, we are here to connect, I think Biplav has a quick announcement, and I think it's an interesting one which you would like to discuss.
You would have seen this at the reception, right? So just in case if you haven't scanned it, this is for a raffle. We are giving home pods. So if you haven't, please do it. We will close the raffle after that, and then we will announce the winner. So anyone? Yeah. Organizers. Anyone pending? All of you done?
I was not able to understand whether my request was successful or not. Yeah, that.
You can try again if you can complete the form. Then it's
give any message. Just again open the same page.
yeah, so it will count only once. So you feel free to scan it if you want.
Sure.
Okay.
No. All right, Jayshree, all yours.
Thank you. Guys, give me a minute. Is it? Cool. Yeah.
All the job postings, all the announcements.
Keynote.
Keynote, okay.
Can I can't?
No, it's there. No, not a problem. You play.
Yeah. And while doing the demo, I'll just take a seat. A very good evening, everyone. And like he said, thanks a lot for coming here after your work. I'm very nervous. My first time in BJUG meetup. And yeah, today my topic is modernize and transform your Java applications to cloud. Why we are talking about cloud is it's one of the fastest and biggest growing environment now with almost a 6 trillion cap. So I just want to have an understanding here. How many of you are from Java background? Oh, good enough. Cool then. I'll get started. I am Jayshree S. Kumar. I am from Java platform group's JCK team in Oracle. Prior to this, I was IBM Java's classes library developer. And while I'm not working, this is what keeps me busy. Today, the agenda is just, I'll just get jumped into it. So what exactly cloud native is, what it means in the Java field, and when you should not be doing this containerization or moving forward, or why would you even have to modernize? And if you have decided that you want to modernize your application, what features the Java ecosystem has? These will be the topics that I'll touch upon. It's a huge topic, but I've tried my best to give it in smaller bits. So what exactly is cloud native? Various cloud platform tools and support providers have their own definitions, but I would say, before me telling, but most of them do agree that cloud native is made up of this microservices. It is container aware. It follows the DevOps methodologies, and it's for the modern world to solve the modern problems. But I would say that cloud native is anything that you do on cloud. By that, I mean, earlier you used to develop, test, deploy all your application in your traditional service. Now in the cloud side, you're just making away with the traditional service and you're going to cloud. But it doesn't mean that just because you've gone to cloud, you cannot directly move your complete application from the traditional service into cloud, because cloud native is going to impact your design, the implementation, and the deployment of your application to get the better benefit. Basically, this is the universally accepted definition. It says build and run scalable applications in modern and dynamic environment. Your modern is this public, private, and hybrid cloud, and those. So now, what is cloud native Java? In its truest form, cloud native Java is nothing but you writing a piece of Java software which will work well on the cloud native ecosystem. they say that for your application to be a cloud native Java application, one of these following features needs to be there. It could be that it is made up of, your application is made up of microservices packaged in container, or it has well-defined APIs for communication. It has support for different user interfaces. It practices DevOps and CI/CD pipeline, or it can dynamically scale horizontally and vertically. This is what they say. But again, let's take that you guys know everything about microservices and you are tired of it, or you don't even want to think about moving your application into microservices. But we are saying cloud native is made up of microservices. So where do you come into picture? You still have a say, because cloud native is not microservices only. Even your complete monolith application that you have, you could still follow this lift and shift philosophy, where you take your complete application, just simply containerize it and move on to cloud. So this way, many companies have seen cost benefits here. The application which is working on your on-prem Java application, they simply take it, they use the same memory that it has been using, they use the same CPU cores that it was using, and with the same Java parameters. They have moved to cloud and people have seen improvements. So this philosophy is like migrate first and modernize next. Once you have migrated your application, you could start with your modernization journey with just modernizing your operations, that is incorporating CI/CD or DevOps methodologies. That will give you a benefit in your development, how you give your application to your user, consumer, and so on. And then you could start by modernizing your runtime. The underneath layer, if you move your runtime from OpenJDK to Graal or Quarkus or Liberty, you will start seeing that it is slowly becoming cloud enabled, your application. You'll save cost, definitely. And finally, modernizing the architecture is taking a big monolith apart into small microservices and going completely cloud native. Yes, I will be coming to it just in a moment. So yeah, so saying you as a Java application developer or Java application owner, you decide that, yes, I want to modernize. So I will containerize myself even before I go into microservices. So then when should you be containerizing? Instead of telling when, I will tell you when to avoid containerization. It is mainly, you shouldn't even think about this containerization if your application is a desktop application, which is rich in GUI. Docker or containers are made for web applications where you get to see maximum benefit there, but not for the desktop application. And then if your application is very simple and if it is small, then also don't go to containerize, because to get the benefits in the Docker side, it's not just that you take your application and put it into the containers. You need to do some more work. And unless your application is big, huge, and has a lot of dependencies, you're not going to see any benefit moving on to Docker, because you could anyways manage a simple thing. And then if you're planning if you have promised your customers that you're going to give a application speed up, that time also you don't have to go on to Dockers, because containerization will definitely speed up your development time, but not the time of your application as such. Then moving on, if there is no need for you to scale, unless you're Amazon e-commerce application provider where you keep having Great Indian Day sales, or you're some, I don't know, some other, okay, I'm not getting it on top of my, if you don't need to scale, you don't have to go there. And if your application has some special hardware requirements like mainframe and all, again, you don't have to go to Dockers. Last but not the least, if you do know the Docker concepts, the cloud concepts, do not go there as of now. If you go, make sure you learn it and then go. Then, yeah, we have seen, yes, your application is not any of these, you do feel I will get benefit of moving to cloud. So what exactly, why exactly are you moving to cloud? Everything is working for you. Why would you suddenly move there? It's mainly, these are the Java, actually, these are the goals of moving the Java applications into cloud. One is you need a fast startup. Then you want lower resource usage, minimum vulnerabilities. You need to minimize your vulnerabilities, and then the compact packaging. Why? Because in cloud, you pay money for how long you use the cloud and how much memory you use. So this should mainly be your goals if at all you do plan to move. So yeah, you have set your goals and you do want to move. Then how would you do? The features that Java provides you. Initially, when all this cloud started up, there were a lot of hue and cry that Java is not fit for cloud. Java doesn't know what cloud is. Java that, Java this, but Java has been evolving. I know it is a very mature language, but it wants its application developers, its consumers to feel happy and be able to get the benefits of the cloud. So Java, this is actually cloud natives, Java's cloud native journey, where it has been trying to give in features that will help you aid in the cloud side. Belsoft put up this very nice nice features where what all Java SDK exactly did for you for cloud. So it started off in JDK 9 where Java introduced compact strings. It's mainly to save the JVM heap space for memory optimization. If you remember, you pay money in cloud for memory and how long you do. So this was one of the attempt. And then since JDK 10, Java has been Docker aware. What it is, I will tell. And JDK 10 has been so long, and even now, even till just 2 days ago when JDK 19 was released, we are still trying to make changes or add in features that will aid you in your cloud journey. Then, on top of that, we came up with 2 low latency garbage collectors, which basically would return the unused memory, where we were teaching the garbage collectors that you can return the unused memory back towards the buffer memory back to the OS. Then yeah, in JDK 12, the Shannon GC was implemented by as an experimental feature. By JDK 15, it became the full-fledged normal feature. And in the elastic meta space, the elasticity was also improved. Again, it has to do with returning the unused memory back to the OS, mainly to reduce all the memory consumption of your Java application. Finally, you'll see that Alpine Linux port, which is the Portella which Oracle started, but where you must be aware of Alpine Linux, the small size Linux. So on cloud, we want small, we want compact, we want everything smaller. So for your applications, Java, Oracle, or the Java provider started giving you the JDK port for Alpine Linux, which is basically built upon the Muscle C libraries. With this, yes, yeah. So I spoke about Docker aware. So before Java became Docker aware, what was happening was the connection between JVM and the CPUs were like this. Whenever your application was running, if it was running on the virtual machine, it will take the your memory, how much memory is available, and the CPU count from the guest OS. While if you have taken your complete application, you have containerized it, and you are running it on your host OS, Java, before being container aware, it used to take the memory and the CPU or how many cores are there directly from the host OS. What this used to do was, JVM actually needs this memory and the core information, because it will then set the default for your JVM compiler threads, your garbage collection threads. But for that, it needed this information. So if your JVM is running on a 32 core node, then, and if you have not overwritten the default, then what will happen is JVM will spawn 32 garbage collector threads, 32 JIT collector compiler threads. And in this way, if you go and spawn 10 containers, you're not going to get any benefit of containerization. It's just going to be a bottleneck. So this is where it started becoming very important, that Java knew how to honor the containers limit, the Docker file. In the Docker file, whatever limit you give, maybe the CPU or the memory limit, it knew how to honor it. That is where this becomes very big. The option that use container support came in. You can enable and disable it. As of Java 10, it is by default enabled. They saw that because most of the guys, okay, how many of you are still using Java 8? So the numbers are lots. So they did think that even people who are using JDK 8, we still want to give you the feature. So they backported this into JDK 8U191 in that update. So yeah, next for the CPU count, the option is this active process count. Whenever whatever you do give, whatever limits you give in your Docker file, these were able to capture them, and then it was able to make your Java, which is running in container, aware that you have to be within your limits. Then there is the option for debugging, and so JDK 11 and JDK 17 are the two LTSs, the long-term support releases. So among them, I mean, in between them, the major were this C group 2 support and the container awareness in the operating systems MX bean. So C group support is a complete, again, a very interesting topic to go and look upon it. This shows how on the Linux kernel, the Kubernetes or anyone are going to take the underlying CPUs into consideration. They have something called as the CPU share, CPU set. Maybe if I just speak in abstract terms, you guys will not understand. But this is needed on the Linux side to maintain the control. Moving on. They also introduced two new options, this max RAM percentage and initial RAM percentage. This is mainly for dynamic heap size. In your containers, if you go and set your XMX and XMS value, what will happen is you'll just go say 2 GB, and then even though you're going to increase your container memory from 2 GB to 3 GB to 4 GB, if it is XMX, it will just remain the same. However, in the percentage, what you're going to do is you'll say, I'm going to give 80% for the heap size. Then as the container memory increases, automatically your Java, your JVM will be able to tune in this heap size value. So yeah, like I said, 2 days ago, JDK 19 was released, and yeah, you are free to go and check it out. So in 19, what we did was, so far, I said there was C group support between JDK 11 and 17, but we found that it was wrong interpretation. They were taking the CPU share from the core Linux. They were considering it for while they were restricting the number of CPUs your JVM could use. This was actually causing the JVM to underutilize the number of resources. That just got corrected in this version, and it's provided. So far, I spoke what all features Java had to help you in cloud. Now I'll speak about the frameworks in the Java environment that you will be able to make use to be able to run on cloud. One is GraalVM. It's mainly for your existing Java applications to run a bit faster. Okay, not a bit. Many people have seen quite a bit faster. It basically, Graal does both. I mean, once you have your bytecode, the regular JIT compiler during your runtime, when your JIT compiler happens, you do a Java main class, and then in Graal has an ahead of time compiler. I'll just be showing that now, which will make your runtime faster. So a small demo here of native image. Okay. I downloaded my Graal from not you. Okay. Yeah, I downloaded from here and I already have it. I'm not very good at the demo part. That is why I have all my commands in. So you see, I have my Graal JVM. I have unzipped it and I go into a small demo. I give a small hello world program here. Sorry? Oh. This is still okay. Mainly, I'll be showing you how Graal is helping you. I mean, this fastness of Graal. So I have my sample hello world program written here. Like I said, because I'm nervous, I'm just gonna copy everything for you. Oh, sorry. Yeah, I forgot. From Java 11 onwards, you just can run. I'm gonna build this into an app, so I will need and manifest. I'm gonna build this into the app jar mainly to get an executable to show the comparison between running it on OpenJDK and running the application, your existing application on the Graal VM. And sorry. Yes, it is production ready, but I don't know if they have any products yet. I'll get back to you. I'll check and get back to you. Right. So this was just my normal Java application, hello world application, which I have the executable here. And I'm gonna set, I already have my Graal VM here. I'm gonna set the path, Java home. So I get my you'll see this is this JDK is a Graal JDK. I will do no. Graal has something called as, it has a tool called native image, and this native image will help you convert your Java bytecode into the native binaries. That is where the fastness comes in. Yes. The runtime execution time is faster, not the initial time. I'll be showing all of that now. Right. Yes. On the OS, it is mainly machine dependent here. What did I do here? This is why I don't like demos. That. Give it just 2 minutes. In the meantime, maybe I'll just go back to the advantages. What happens in just-in-time compiler is, oh, this is not big enough for you guys. Okay. I don't need this for now. Yeah. So during runtime, you need to load your jars from the disk. You need to verify the class definition. You need to execute the interpreter, gather all the profiling feedback, and then run it on your machine code. Whereas in ahead of time compiler, you just load the executable from the disk and you directly go ahead and run. I think we have our executable is still building. This, if you notice, this will be one of the disadvantages that I will be talking about Graal in a minute. It's taking some time. Yeah, it's done. In 1 minute, it is here. So mainly what I wanted to show was when I run the regular OpenJDK, your executable, the time taken is around 0.4 second. Now I'll run them. You'll see it is more than how many percentage? 0.44, 100 more, I mean faster. It's faster, basically. Yeah, 10x faster. So it's like your regular C that you use. So it created this main binary. I simply run it as an executable. Sorry, please repeat the question. Right, right. Right, yeah. It is not, it is a bit bigger, but not very big. What do I do? This, but in the sense of the application side, it does becomes big, but it's not, it's a trade-off. You're still okay if you get a faster startup time. Yeah, but that's a very good point to note and study about on a bigger applications. I'll definitely make note of that. So you saw that the time is faster, and coming here, that was one of the advantage. It's faster because it just takes the executable and runs it. And this also you're also saving up in memory, because during JIT time, your dynamic code cache, your meta space class files all will take time. Whereas on the runtime in the cloud, it basically matters your runtime memory. So there, your Graal doesn't take that much time. So far I spoke about advantages, but now coming to disadvantages, you will see that because Graal has to do all its ahead of time compilation and the homework, it doesn't support dynamic class loading. One, it's because of the security reason, and another because it's a big pain suddenly getting a dynamic class, which it cannot even make sense of. And before for Graal to make sense of your application or get to the executable, it needs to have, your application needs to have a reachable metadata. If it doesn't, again, it will not be able to give you the executable. Then the slow build time. You saw when I was actually building the execution, it took 1 minute. It's like a big thing. And even for the first initialization time or the build time is high on Graal, definitely. And it doesn't allow profiling to gather during the build time. And when I said no dynamic class loading to the developers, it will mean you will not be able to use reflections that much, if at all you prefer reflection. It is not that it's completely removed reflections, it's just that it has limited, and if your application uses reflection, you will have to do a manual mapping in Graal. So it requires a manual intervention. This is where like Satish just said, it has not become that that taken, but people are slowly taking it, and they are spending more time to investing more time to see where they can take it, because once they have got this initial thing set up, it's going to be very fast for them in the cloud world. The next framework that I will be talking today is about Quarkus. Code time, compile time, and the code time you will be doing, and the execution, basically you'll be giving the reachability metadata, so that when you run it and before you get your executable file, you need to do all these things. So there'll be some additional things that you'll be doing. That is why it was not. Yes. Yes, the native image will fail. I mean, you'll not even get the native image, and it'll not be done properly also. So then moving on, we are coming to Quarkus. This is one more new modern framework. You can say, why are you talking about Quarkus and not Spring Boot? Spring Boot, like Java, is very mature. Yes, they want to move on to cloud. They are doing all that they can do. And there is Spring Boot, Spring Native project also, which is going on. They're trying to fit in everything, but then it was not made for the modern world, whereas Quarkus is made up. When it was built itself, it was made in such a way that it basically works on the funda that it wants to do away with the dynamics of the regular your Java SE, your regular Java SE, where it says that in cloud, once you make your application, there is no way that it can change during the runtime. Your application, whatever you have built, it will keep running the same thing again and again. If it's Amazon shop, your cart will have one specific feature. Your search will have just one specific functionality. You're not going to change. So Quarkus says that it's going to give a custom runtime where it will do it with all the dynamic things and the huge things that Java OpenJDK comes with. So that is where it becomes subatomic. It's 10x smaller than your OpenJDK. It is supersonic. They say it runs very fast, and it has support. Actually, Quarkus gives out both JVM. I mean, sorry, executable to be run on JVM and executable to be run on GraalVM also. So in this way, the speed is also faster, the runtime speed, I mean. And it has a lot of new features that developers nowadays are looking for. It is both imperative and reactive program. A small example for imperative and reactive would be that if A is equal to 10 and your B is A plus 1, and when you make A is equal to 11, in imperative program, B will still continue to be 11. Whereas in reactive program, your B would have already become 12. That's what Gyana was trying to explain. As your producer is giving, the consumer will keep consuming it. So these kind of programming, asynchronous programming, are becoming famous. And that is where Quarkus says, no problem. If you want reactive in your application, I am here to provide you that. Basically, it is made up of best of Java libraries. It has Netty for your reactives. It has a lot of microprofile and Docker. It's made up of it has Kubernetes also. It is a bunch of libraries together, making your Java application developers' life easy. So a small demo on. I hope. Okay, I'm running late. 5 minutes. I've eaten up 5 minutes of your time. Just very quickly do this. So if you want to get started with Quarkus, it's very simple. And if you were a Spring Boot, if you are already using Spring Boot, this should be interface that you guys will be very much aware of. I'm just gonna do a small hello world program again, a REST API where it's gonna expose the hello endpoint. I will do my com.quick demo, QR demo. I will say a sample that I'm creating with what you want to build, that also is there. And then Quarkus, like I said, it allows the application developer, it gives all the libraries. So you can pick and choose what all extensions you want to be able to use in your Java application. You can come and pick and choose here. You do a, I have just taken this Hello World program to show again the speed at which it will run, how fast Quarkus runs your Java application. That is what I wanted to show. So, just open it up. Basically, it would have just created a Maven structure. The demo that I just got here, you have your source, you have your resource, which is gonna expose. It's just a greeting resource which is gonna expose an hello endpoint. You go view it there, and you will see that as soon as you start your application, you'll be able to go and you'll be able to see, fetch your resource at localhost. Yes, coming to this, it also comes packaged. See, Quarkus is also going to give you your unit test along with it. It makes your life easier, and your POM file is there for any of the configurations that you want to add or say. I mean, if you are in Spring Boot and web application development space, you will already know all of these things. So I'll not talk much. I will start my like I said, is this visible? So at this endpoint, all I'm doing is I'm returning in, let's say, my, oh, it's still taking time. Okay, my application just started. So at the hello endpoint, I should be able to see my hello bject. And like I was saying, Quarkus, because it's a modern language, it has a lot of features, developer joys that it speaks about, where I simply do my changes and immediately I'll be able to see it. This is the hot reload. And Quarkus also supports your dependency. It has inbuilt dependency injection, which basically it'll help you loosely couple your application. It'll for better not having too much of dependency. Actually, Quarkus has a lot of features which I'm not talking yet, but yeah. So maybe I'll not. I'll just continue with this and close it. Once you are done with your application, you could package it both to be run on VM and to be run on Graal VM. So to package it for running on VM, all you'll do is Maven package. I'm just gonna package and I'll just quickly show the time between both of it. Basically, I mean, I don't have to tell. Yeah, this will fail now. Yes. Ach, the configuration. Is this big enough? I don't know. Should I? No, how do I? I'm trying to mute this also. This. Oh, okay. Thank you. No, This is Quarkus is building this for you. Right, right. You'll need to search for an alternative here. People have done many Spring to Quarkus refactoring or movement. So there, Quarkus does have a lot of libraries, like I did say. So anything that is there in Spring, you'll be able to find most of them on Quarkus too. Yeah. Yeah. Yeah, .io, that is exact copy of Spring. Yes, I know. Right, Java to Kotlin and Spring to Quarkus, you can. Familiarity, right? They don't want developers to suddenly, I mean, for 20 years I was coding in Spring, and you want me to come to Quarkus, who will even come unless it feels same? And they say you definitely get an advantage on it. So yeah, this failed because it was expecting this. When we made the package, it was expecting that. What did I give now? Integration. Yeah, I could have, but I was just so I forgot. While after I did, I realized I should have done that. Okay, it's getting delayed. Okay, because I have run short. Basically, when I run both of these things, you'll be able to see the same amount of time that you were seeing when I ran with the regular JDK and the Graal VM. With that, yeah, the advantage here, you can see that Quarkus with Graal, it takes how much of memory, and then how fast it is. They do sell Quarkus with this part, and many of the applications who have done this strip, they have seen the advantage on both the memory and the time to first response. But again, Quarkus also has its disadvantages because it's new. It doesn't has a complete support for E standards, and you saw that it does. Like Graal, it has a highly optimized build process, meaning it takes long initialization time. Again, it restricts the dynamic informations. With that, I conclude my talk. So I would just say that modernization is a journey, and it's here to stay. Just because something is fashion, do not follow it. You do your due diligence. You check if your Java application does fits in the container world, and if it does, then what are the implications, what runtime you want, how much CPU is needed, and all those things. And finally, if you're gonna achieve the benefits that you just went out to, but that is what, start by knowing it all. I'm open for questions. I know it's 7:45. If anyone has any questions. Okay, thank you. I either did a very good job, or it's too late, or I did a very bad job because I didn't get a single question.
No, I think there's enough time for Q&A, and both Gyana and Jayshree, they're here, so you get enough time to connect with them and ask questions. Okay. Thank you once again for coming in here and attending this entire meetup. You see a nice red box here, right? So this is something which we are giving, and then there are some other goodies which you'll get it when you leave actually from our office. But let me probably ask you a few questions before I give this. Not the questions to the gift for the questions, but more like just to check. Who all did you engage or interact from JFrog? Do you remember any JFrog employee's name? Okay. Prasanna. You got my name wrong, Jayshree. I'm sorry. I'm hurt. Thank you. I'm really hurt. Okay, good. Do you know when did we start? Sorry? 6:10? No, not the meetup. When did we start as a company, JFrog? No, I was just asking out of curiosity if you have done any. When did you, if you've done any research?
Sounds like an introduction into JFrog.
No? Ah, okay. Let's cut that. Okay. Yeah, so some estimation when, which year we started. Globally, company, JFrog.
I mean, there's no right or wrong answer. You can
Yeah, you can guess.
2008, 2007,
2016?
Someone just Google 12, 2008. Okay. What is J in JFrog?
Yeah. Good.
Why guess?
No, he said already. Amazing. Okay, thank you. It was just to make sure that you are all awake and you did not sleep. No induction, meeting, etc. So yeah, just to make sure that you are awake. And we have some snacks also outside, just to make sure that you are not hungry, because you have to again travel back to your place, and we understand how much traffic you have to cross through. Okay, so now, did all of you fill this registration form? Because there was one name which we could not find. A name called Jay Kumar. Who's that? But your name is not here, so. No, I could not find it. So why you didn't sign this? No, you haven't, right?
Vijay Kumar Ravindra. So that's it.
Ah, okay. All right. So you can stay here because you are the winner of this home pot. Thank you. Thanks for coming in. And yes, thank you. Yeah,
In fact, 2 days back, I got a webinar from JFrog Israel team.
Oh, is it? Wow. So you're actually doing some research on JFrog.
We are using
Amazing. You're using amazing.
X-ray and mathematics.
Great. Thank you so much. Alrighty. So do we have anything else?
For the speaker, last time that we shared with because
Just going to speak.
All right.
I'm not getting it.
Please.
Yeah, well done.
yeah, we have another speaker.
Thank you. Yeah, I got this.
Awesome. My own gifts.
But I think there are some JFrog stuff also for them, right? So.
Yes, we have.
Alrighty, so I think that's it from goodies point of view. But yeah, there are snacks, and do collect your goodies, the JFrog goodies, before you leave. That's at the reception. Yeah, now let's get to snacks and networking. All of us are here, so if you have any questions, feel free. Okay. All right, let's get started. Thank you. Thank you so much.